Welcome to Easy BTech, your guide for BTech and beyond. In this video, we'll learn about how to calculate ABCD parameters from the given data. From that, how we can calculate sending end voltage and regulation. First, we will see the problem or data they will provide in the problem. The problem is a balanced three-phase load of 30 megawatt is supplied at 132 kV, 50 Hz and 0.85 lagging of transmission line. Okay, and they will provide the series impedance Z equals to 20 plus J40 ohm and shunt admittance Y equals to 315 into 10 power minus 6 mho per phase values. Both are per phase values. Use nominal pi and T methods to determine. First one is ABCD constants. From that we can calculate sending end voltage, and third one is have to calculate percentage regulation by using these two methods. Those are the information they given in this problem. First we will see what is the information they given. Now they given it is a three-phase system. In three-phase system we have to calculate VR per phase. They will provide line voltage, then we have to calculate VR per phase. That is the indication, that's why I am writing phase. And they given the load is nothing but receiving end power 30 into 30 megawatt. 30 megawatt is nothing but 30 into 10 power 6 watt. And they provide 132 kV is the receiving end voltage. Therefore VR, this is line to line voltage, is 132 kV. 132 kV is nothing but 132 into 10 power 3. And power factor cos pi r they given 0.85 lagging, and they given the series impedance Z equals to 20 plus J40. If you convert this 20 plus J40 in polar form, it is 44.72 at an angle 33.43 in polar form. Okay, it is very convenient to substitute the values in polar form. Okay, that's why I'm completely converting all the terms into polar form. Now admittance, they given admittance equals to 315 into 10 power minus 6. Actually this is J. I am writing in polar form. It is 315 into 10 power minus 6 at an angle 90. Okay. Solve problem in polar form. It is very easy. Okay, compared to in rectangular. All the values, they automatically they given magnitude and angle. Okay, it is very simple to calculate the problems in performance of transmission lines. That's it, they given. And first case I will use the nominal pi method. We know the nominal pi method. The ABCD parameters are A equals to D equals to 1 plus ZY by 2 and B equals to Z and C equals to Y into 1 plus ZY by 4. Okay, those are the formulas for calculating these ABCD parameters. Now by substituting the values of Z and Y, first of all I have to calculate ABCD parameters and A and D parameters in ABCD parameters. 1 plus ZY by 4, 1 plus ZY by 2. Therefore, it is 1 plus the Z value equals to 44.72 at an angle 63.43 into Y value equals to 315 into 10 power minus 6 at an angle 90 divided by 2. Divided by 2, we get this value is 1 plus 0.00704 at an angle 153.435. In polar form, we will get 0.9937 plus J 0.00315. In polar form, the value is 0.9937 at an angle 0.1816. Those are the values for A and D. A and D for this case. Next, B equals to it is nothing but Z. It is 20 plus J 40 or 44.72 at an angle 63.43. B equals to C equals to Y into 1 plus ZY by 4. Already we know the value of Y. It is 315 into 10 power minus 6 at an angle 90 into 1 plus 44.72 at an angle 63.43 into 315 into 10 power minus 6 at an angle 90 divided by 2. Sorry, it is 4. Divided by 4, we get 315 into 10 power minus 6 at an angle 90 to 1 plus 0.00352 at an angle 153.458. After calculating this, we get the value is 314.01 into 10 power minus 6 at an angle 90.0905. Those are the ABCD values for nominal pi method. I am writing separately for ABCD calculated value. A equals to B equals to C equals to D equals. A and D are having same values. Therefore, 0.9937 at an angle 0.1816. This is also 0.9937 at an angle 0.1816. P equals to 44.72 at an angle 63.43. Y equals to 314.01 into 10 power minus 6 at an angle 90.0905. Okay, those are the ABCD parameters in a nominal pi method. Therefore, after calculating this in nominal pi method, after calculating this ABCD parameters, we have to calculate the sending end voltage. The sending end voltage is equals to, first of all, before going to the sending end, we have to calculate the phase voltage. The phase voltage is receiving end phase voltage VR phase equals to VR line to line voltage divided by root 3. This value equals to 132 into 10 power 3 divided by root 3. We get 76210. I am taking it is the reference, that's why at an angle 0 voltage per phase. And for calculating Vs, I have to know the IR. IR equals to receiving end current. IR equals to, we know the formula, PR by root 3 VR, a line to line voltage into cos pi. The given PR equals to 30 megawatt, therefore 30 into 10 power 6 divided by root 3 into VR. PR is line to line voltage is 132 into 10 power 3. Power factor the given 0. It is 5R, 0.85. Therefore the current is 154.37. IR vector, we represent IR vector is IR at an angle minus 5R. Okay, I know the magnitude of IR, it is 154.37. Therefore minus of, how I can calculate this 5R? 5R is nothing but cos inverse of 0.85. You get this value is equals to 31.79 amperes. Okay, now I can calculate the Vs. Vs equals to, the formula for Vs equals to AVR plus VIR. A value is 0.9937 at an angle 0.1816. VR value is 76210 at an angle 0 plus V value is 44.72 at an angle 63.43. The current value is 154.37 at an angle minus 31.79. Okay, substitute all the values here, we get the Vs voltage. How much you get Vs voltage? Vs voltage equals to 81698 at an angle 2.7 volts. If you want to calculate the sending end line to line voltage, multiply the above answer with root 3 magnitude only. 81698, you can get the sending end line to line voltage is 141.505 kV. Okay, after calculating this, Vs is also calculated. This is Vs per phase. Now I can calculate the regulation. The regulation equals to the percentage regulation. We know the formula, V no load minus V full load divided by V full load into 100. Here V full load is VR and V no load is same formula. We know that Vs equals to AVR plus BIR. Here IR equals to 0. Therefore this is the no load voltage. No load voltage at the receiving end, V no load equals to, this is this becomes the, if IR equals to 0, this one becomes Vs equals to AVR at no load. Therefore the receiving end voltage at no load, V no load equals to Vs by A. Okay, therefore substitute this one in V no load formula. Therefore percentage regulation becomes Vs by A at no load condition minus VR by VR into 100. But if you know the A value, we can use this formula. First I have to calculate V no load. V no load equals to Vs by A. The Vs value is 81698 divided by the value is of A is 0.9937 at an angle 0.1816. This angle is 2.71. After calculating this, I get this value is 81919.098 at an angle 2.63 volts. Then I will calculate the percentage regulation. Percentage regulation is Vs by A minus VR divided by VR into 100. Therefore the Vs value is, the no load value is Vs by A just now calculated, 81919.098 minus 76210 divided by 76210 into 100. You can get the percentage regulation for nominal pi method is 7.49 percentage. Okay, this is the way we will calculate ABCD parameters, Vs and percentage regulation in nominal pi method. Like that we have to calculate in nominal t method. How we can calculate in nominal t method. In t method also we know the expressions for ABCD parameters. A equal to D equal to 1 plus Zy by 2. B equals to Z and C equals to in a nominal t method Z equals to Z into 1 plus Zy by 4 and C equals to Y. Okay. Now already I calculated ABCD parameters. A equals to 0.9937 at an angle 0.1816 and D also same value 0.9937 at an angle 0.1816. C equals to Y, it is nothing but 315 into 10 power minus 6 at an angle 90. The only value we have to calculate for T method is B, that is Z into 1 plus Zy by 4. Okay, already calculated in nominal pi method, same values here also. But B is different for nominal T compared to nominal pi. The Z value is 44.72 at an angle 63.43 into 1 plus 44.72 at an angle 63.43 multiplied with 315 into 10 power minus 6 at an angle 90 divided by 4. Therefore, here we get for B is 44.72 at an angle 63.43, 1 plus 0.00352 at an angle 153.435. After adding this, we get 44.579 at an angle 63.521. Oh, this is the value for B. And now I will calculate the sending end voltage. Sending end voltage Vs equals to A VR plus B IR. Already we know that values. A equals to 0.9937 at an angle 0.1816. VR equals to 76210 at an angle 0 plus B equals to just now calculated B 44.579 at an angle 63.521 into the current is 154.37 at an angle minus 31.79. Okay, by multiplying this we can get the sending end voltage is 81673.81 at an angle 2.7. Okay, this is the value for sending end voltage. Now we will calculate the percentage regulation. Percentage regulation equals to V no load minus V full load divided by V full load into 100. Once we know the A value, then automatically the no load voltage is Vs by A minus Vr by Vr into 100. Here Vs by A is 81673.81 divided by 0.9937 at an angle 0.1816. It is 2.71. We can get the no load voltage. The no load voltage is no load. This is V no load voltage. Therefore, V no load equals to 81894.882. Okay. Now the percentage regulation equals to, this is no load voltage magnitude 81894.882 minus 76210 divided by 76210 into 100, can get the regulation is 7.46%. Finally, I concluded that with the nominal pi method, I get the regulation is 7.49 percentage. With the T, I can get the regulation is 7.46 percentage. So this is the way we will calculate with the help of nominal pi and nominal T methods. If they will provide impedance and admittances and line data, from that we can calculate the ABCD parameters. From that ABCD parameters we can get the sending end voltage and regulation. This is the easy way to calculate the performance of transmission line once we know the ABCD parameters. Thank you for watching.